Hey everyone, welcome to homework 5.3. Today we looked at being able to factor our, let's see if we can get this to allow me to grab the right draw tool. All right. There we go. Okay. Okay. All right. So today we learned how to factor quadratics, and so we learned earlier how to multiply, right, when we are in factored form to make it standard form by using either FOIL or the square method. This time we're working backwards. We're going from standard to factored form. So to do this, a big thing is knowing your multiplication tables. So it's find two numbers that satisfy the requirements. If you get stuck, try listing out all of the factors. Remember, all the factors are the numbers that can be divided evenly into the number without any remainders. So find two numbers that multiply to add to 17 and add to 18. So 17 times 1 equals 17, and 17 plus 1 equals 18. So those are my numbers, 17 and 1. Two numbers that multiply to 20 and add to 9. So I can list out 10 times 2 is 20. We can say 4 times 5, I was trying to add to 9, 4 times 5. Now 10 plus 2 gives me 12, that does not equal 9. But 4 plus 5, so 4 times 5 equals 20, and then 4 plus 5 also equals 9. So that gives us the one we're looking for. Two numbers that multiply to 11 and add to negative 12. Ooh, this is an interesting one. So two numbers that can multiply to equal 11 are 11 and negative 1. We can also have, that equals negative 11, so 11 and 1. We want it to multiply to be positive 11, and so it can be negative 11 and negative 1, and then negative 11 plus negative 1 gives me negative 12. So that works out pretty nicely. All right, and then if I'm finding two numbers that multiply to 36 and equal negative 20, I'm probably going to be looking at two negative numbers because I need to get a positive answer and then adding to be negative 20. So let's see, we have 9 and 4. 9 times 4 gives me 36, but added is not going to be negative 20. We have, let's see, 12 and 3, that equals 15. So we need to go with some bigger numbers here. Let's see, 18 and 2. Well, 18 and 2 does equal 20, but I need it to be negative 20, so I'm going to make it negative 18 and negative 2, because a negative times a negative will give us a positive, but a negative 18 and a negative 2 will give us negative 20. So this kind of thing right here that we're doing takes a little bit of thought, right? And it's going to take some trial and error. You might not get it right away. That's okay. You can go through the process. So this is asking us to show the diagram that this factored form is equivalent to standard form. So x times x equals x squared, 2 times x equals 2x, 4 times x equals 4x, and 2 times 4 equals 8. So then I can combine the 4x and the 2x, right? So we get x squared plus 6x plus 8. Now here, we're going to do x times x is x squared, negative 10 times x is negative 10x, negative 3 times x is negative 3x, and negative 10 times negative 3 is positive 30. So I can combine these and do x squared minus 13x plus 30, right? Combining these because they're like terms, and we get the same thing as this. So we know that that is true, and we've proven it. Number 3 says select all expressions that are equivalent to x minus 5. So x plus a negative 5 is the same as x minus 5. X minus a negative 5 is the same as x plus 5, so that's not true. Negative 5 plus x. So this can be written as x plus negative 5, which means commutative property tells me I can rewrite this as negative 5 plus x. As long as the signs in front of our numbers or in front of our variables remain the same, that works. So this one does not work because that has a negative x, and in our equation the x is positive. So we know that this one with a negative x does not work. 5 minus x, so again, here we have a positive 5 and a negative x, but in our original equation we have a positive x and a negative 5, so that is not true. This can be rewritten as negative 5, negative times a negative, or minus a minus is going to be plus x. So this is the same as this one because I can rewrite this as x minus 5. And then 5 plus x, here we're missing that negative sign in front of the 5, so that is not true. All right, number 4. Here are pairs of equivalent expressions, one in standard form and the other in factored form. Fill in the missing numbers. So here we're starting with it factored form. We want to put it into standard form. So what I need to do is multiply negative 9x and my outside, which is negative 3x, and then my last, which is plus 27. So in the parentheses here, this is going to be minus 12x, and this is going to be plus 27. Oops, excuse me. Let's look at the next one. So this one now is working backwards. So in this one, it's giving me the first one. I need to figure out what times 4 is going to give me 32 and add to equal 12. Well, 8 times 4 is 32, and 8 plus 4 equals 12. So I know that that works. Here I have a 5 here. Notice I have a negative 5 here and I have a positive 35. So we have plus here. So I want it to be a overall positive number, which means I'm going to be multiplying by something negative here. So 5 times 7 is what equals 35. So negative 5 times negative 7 gives me positive 35, and negative 5x and negative 7x will give me negative 12x when I add them together. So remember, your constant term is looking at your last two parts of the factors being multiplied together, right? And then your middle term or your linear term is being added together. It's that middle part and that end part being added together. All right, so then our last one, we have a minus 4 here. We have a plus 20. So we know this has to be a minus whatever it is. And 4 times 5 is 20. So this would be times a negative 5. Remember that this is x plus a negative 5 is the same as x minus 5. Okay? All right. It says find all the values for the variable that make the equation true. So this is b times b minus 4.5 equals 0. Remember what we're doing here is we're taking each factor, right? And each factor is one of the things being multiplied, right, by the other. Because a factor means it's divisible evenly, right? So these are each factors. So b equals 0. I'm splitting the factors and setting each one of them to 0. So here I'm going to add 4.5 to both sides, and I'll get b equals 4.5. Now, I know this seems like a silly step because you might think, I can do that in my head. But when these numbers start to get more complicated, it will be more difficult for you to do it in your head. So I want you to practice showing your work because it's going to get you into a good habit. Now, these two right here are the same, right? And so we can just do one of them, x squared plus 14 equals 0, minus 14 on both sides. So 7x equals negative 14. Divide both sides by 7, and we get x equals negative 2. This is an example where we have that negative sign, and so it might get tricky. It's important for you to write out each step. All right, 2x plus 4 equals 0 is one of them. Subtract 4 on both sides. We get 2x equals negative 4. Divide both sides by 2. We get x equals negative 2. And then we need to solve this one. X minus 4 equals 0. Add 4 to both sides. X equals 4. Now again, that's one that you can see, probably just by looking, you can reason 4 minus 4 equals 0. But again, showing your work will get you into good habits. Let's look at the last one. The last one has an interesting negative thing going on. Again, a demonstration of why it's good to show your work. Let me shift colors just a little bit here. So we have negative 2 plus u equals 0, setting the first factor, and then 3 minus u equals 0. So for this first one, because I have a negative 2, I'm going to add 2 to both sides, and I'll get u equals 2. I can check that. Negative 2 plus 2 is 0. That works. Now here, I can subtract 3 and then I'll have negative u equals negative 3, and then I can divide by a negative. Or I can very simply add u to both sides instead, and I'll get 3 equals u, and we can test that out because 3 minus 3 equals 0, so we know that that is true. Again, these quadratics are often going to have two possible answers. Number 6, Lynn charges $5.50 per hour to babysit. The amount of money earned in dollars is a function of the number of hours that she babysits. Which of the following is impossible for this function? So inputs are number of hours she's babysitting, right? Function of time, so time is the input. So -1 is the only one that would not work here, right? Because we're not going to have negative hours. We won't make any money that way, and we can't really count time that way in terms of giving time to someone for babysitting. It says, consider this function, evaluate p of 1, writing out every step. So this is a review of our functions. So here, instead of x, you're going to change everywhere you see an x for a 1. So we'll have p of 1 equals 1 minus 3 times 2 times 1 minus 6, or 1 minus 3 is -2, 2 times 1 is 2, 2 minus 6 is -4. -2 over -4 can both be divisible by 2, by -2, because they both have a negative sign, so this is 1/2. Evaluate p of 3, writing out every step. So p of 3 equals 3 minus 3 over 2 times 3 minus 6. 3 times 3 is, 3 minus 3, right? Yes, 3 minus 3. See, writing clearly, super important. 3 minus 3 is 0. So 0 divided by anything is going to be 0, but we also have 2 times 3 is 6 minus 6 equals 0. And note here that we cannot divide by 0. So what does that mean? That means that this is not possible. 3 is not a possible solution. And a possible domain for p, that means that it could probably be less than 3, and it can also be greater than 3, but not equal to 3. Okay, so that would mean that x is less than 3, or x is greater than 3, but x cannot actually be 3. All right, number 8, technology required. When solving this equation, Priya graphs, and she graphs y equals 2 minus x times x plus 1 minus 11. So she moved this 11 to the other side, and she looks to find where the graph crosses the x-axis. Tyler looks at her work and says graphing is unnecessary, and Priya can set up the equations 2 minus x equals 11 and x plus 1 equals 11, so the solutions are x equals -9 or x equals 10. Do you agree with Tyler? Well, let's see what he does. If he does -9 here, that would be 2 minus -9, right, times -9 plus 1. This would be 2 plus 9 is 11. So that one equals 11. But then we have -9 times 1, which is -8. This gives us -88. That does not equal 11. So Tyler is wrong. No, because this only works when it equals 0. Okay, so you can't set each factor to a number that it equals unless that number is 0. So here we can't say that each one of these equals 11. The reason it works for 0 is because anything times 0 equals 0. So if any one of these equals 0, the whole thing will equal 0. But if one of these equals 11, that doesn't necessarily mean that the whole thing will equal 11. Right? It says, how many solutions does the equation have? Find out by graphing Priya's equation. So let's go ahead and do that now. All right, so I've gone ahead and I've put the equation in that Priya came up with. So 2 minus x times x plus 1 minus 11. And I'm going to go ahead and graph this. And mine is not set, so let's go ahead and put this in standard form. All right, so now I can see that this is all the way down there at the bottom. Let me go check and make sure that I put my equation in here correctly, because I feel like that graph doesn't look quite right. 2 minus x times x plus 1 minus 11. 2 minus x times x plus 1. All right, let's check and see if I got that right. 2 minus x times x plus 1 minus 11. Okay, that is correct. All right, so now let's take a look at this. And it's down below there, so I'm going to change my window to a negative y value. Let's try negative, it's minus 11, so it's going to be below that. Let's try minus 20 and just see what we can see there. Okay, that's a lot better. I can see a little bit more here. All right, now let's go back to our it says, how many solutions does the equation have? Find out by graphing Priya's equation. So when we look at this, we want to look at where it crosses the x-axis. How many solutions does this actually have? Well, let's go back and look at that graph. There's no place that it's crossing the x-axis, right? So let's see what happens. If I were to take away this minus 11 here, and instead put 11 here, and see where does the line cross, and I graph it, ooh, notice here, let me do 6 standard, and actually we need to be able to see at least 11, so window, we'll make our x, or y max rather, 12. So that y equals 11 is up here, but the graph is down here. So since they are never actually touching each other, this graph right here is never going to equal 11, which means that, it's a good thing that she graphed it, right? That there's no solution here. So here there are 0 solutions. All right, let's look at, you have 2 park problems here to help you practice for the actual park. So this quadratic function represents the area in square inches for a rectangle. Which function gives the area as a function of width? So if we were to plug in the width, which one gives the area as a function of the width that would actually make sense, right? So keep in mind that in our rectangle, we would have a width, right? And then we have a length. But we're saying that we only want to put in this value for width without the length in there. And we're looking for the area. So it's asking us, how could we possibly represent that? So for this one, you're actually missing a bit of information. So you have to watch this video for this. So I'm going to give you that information right here. And let's go ahead and give you that information right here. So here's the information that you're missing. The length of a rectangle is 7 inches less than twice the width of the rectangle, W. So the length equals 7 inches twice the width. So that's what the length equals, right? So if our area is width times length, it would be width times 2W minus 7, because this represents the length. And so then our area would be 2W squared minus 7W. And so the best one that matches here is D. Part B says, if the area of the rectangle is 60 square inches, what is the width of the rectangle? So if the area is 60, then we have this equation here, or this equation here, right? We have W times 2W minus 7 equals 60, right? We want to figure out what is the possible width of the rectangle. So let's go ahead and take a look at this. Well, here's something interesting. I cannot just move this or set each factor equal to 60 because they don't equal 0, right? So I need to look at this in a different way. So let's look at this using our calculator. I'm going to go back. Maybe it's being stubborn. Okay, here we go. And I'm going to go in and I'm going to put my calculation here, which was x times 2w minus 7, so 2x minus 7. So x times 2x minus 7. Oh, I hate it when this happens. Click it. There we go. 2x minus 7. And I want to see when that will equal 60. So let's graph. Now, in order to see this, I'm obviously going to need to set my window up to be much greater. So let's set it up to 65. We don't need anything negative here. Change that to that. And let's take a look at our graph now. Ooh, so now we can see where it equals 60. Well, over here is negative, so we're not going to have a negative value for our width, so we want to look at the positive intercept. So I'm going to do second calc, and I'm going to press 5 intersect, and then I'm going to move up to this first curve. Maybe. Where is my... Oh, okay, there we go. There it is. And hit enter. Then I'm going to move on to my second curve. I'm going to say enter. Guess, yes. So the intersection is at 7.5. So the answer here would be 7.5. Because at 7.5 we would have 7.5 times 2 times 7.5, and 2 times 7.5 is going to be 15. 15 minus 7 is going to be 8. And so then if you do 8 times 7.5, you will in fact get 60. Okay? All right. It says, which equations have no real solutions? And select all correct answers. So let's take a look at figuring this out. So one, we want to figure out when will this not work, right? And so if I do 0 divided by 2, I will just get 0. And so I'll have x minus 3 squared equals 0. I can take the square root of both sides. That'll fine. So this looks like it has real answers there. Okay. For this one here, if I go ahead and move this to the other side by subtracting 4, I'll get 2 times x plus 3 squared equals negative 3. And then I'll have x plus 2 squared equals negative 3 divided by 2. And then if I take the square root of both sides, I cannot take the square root of a negative. If I take the square root of a negative, that gives me what's called an imaginary number. So this equation has no real solution. Oh, I'm sorry. So actually, this is the opposite. The number 1 does work, and it says which equations have no real solution. So B does not have a real solution. A does have a real solution. B does not have a real solution. C, if I subtract 4 from both sides, I'll have a positive number. I'll have 4. I can take the square root of that, so that one does have a real solution. D, if I subtract 4 from both sides, I'll have a negative number. So this will be x plus 1 squared equals negative 2. Again, I can't take the square root of a negative 2 without getting an imaginary number. So D does not have a real solution. And then lastly, letter E right here. Well, this one is a little bit tricky here because it's not as simple to see, but let's go ahead and put this 15 back on the other side. So if I do x squared plus 8x plus 15 equals 0, right? When I add 15 to both sides, I'll have 0. Now I can factor this, and I can do x plus 5 and x plus 3, because 5 times 3 is 15, and 5 plus 3 equals 8. And so now I can have negative 5 and negative 3. So this has 2 real solutions. So E does not have an imaginary solution. It has a real solution. All right. So just to reiterate, if we have a negative number in the square root, that gives us an imaginary number, which is represented with kind of this cursive-y looking eye. And so that is not a real solution. They're called real versus imaginary numbers. You'll learn more about them. You really just need to know that if we take a square root of a negative number, it does not give us a real number. It gives us an imaginary number. And then to reiterate back up here with this rectangle piece, if you wanted to find the solution with 60 here, then you would need to go ahead and calculate, putting in your calculator, when does this equation equal y equals 60, right? And we can look for the intercept there to find that answer when we're using your calculator. In a couple of lessons, you'll have an example of how you could solve that without the calculator, but for now, this is the piece that I really want you to know, okay? All right, your code word for today shall be babysitter, since we had a question about a babysitter today. So that's your code word for today. Make sure that you practice these. If you have questions, let me know. Strongly suggest you review your multiplication tables. Happy homeworking and see you tomorrow.